tissues, right? You start the first drawing, which should be the cell, and then you have the different tissues there. And I want you to draw one organ, which is the skin. So that you know how a slide of an organ looks like, you should have two tissue types there, at least two. The skin, the topmost part is epidermis, and then the deeper part is dermis. We're going to study it and we're going to look at it. So that's part of your drawing. You're also going to draw mitosis, the different phases of mitosis. But in your lab exam, if I say identify this organ, that should be your clue, right? The answer is always the and only the skin for the lab exam, because that's the only organ I'm asking you to draw. So that should be the only correct answer. And it really is the skin. You will see it, the epidermis with the hardened keratinocytes. So it's obviously the skin. Don't struggle as to what answer should be written there. And then in the lab exam, if it doesn't, because all my questions, there will always be follow-up questions. So the first will always be identify, and then the follow-up questions, you're supposed to answer in relation to your answer, the tissue type that I'm asking you to identify. If it doesn't make sense, then that means you answered it incorrectly. Okay? And like I said, I know it's coming up soon, but the good news is students have been doing very, very well in their histology. Just pay attention, and if there's anything confusing, then let me know so that we can discuss. So let's review again your tissues.
Are these tissues on our PowerPoint? Yeah.
Yes. Yeah. It was on it's on Canvas, right? Yes.
It's in the files. Okay.
And then there's very nice websites. One is, do you know of the Kaplan Anatomy Coloring Book? Mm-hmm. It's a free website, PDF. You can download it. Kaplan Anatomy Coloring Book. And if you get on that website, I think you can save it to your computer, and everything is in there from chapter 1 to the end of the book. This one, Kaplan Anatomy Coloring Book. Then there's also Histology World. There's also, my other favorite is, what's that one? Kaplan Anatomy. Here, see, it's free. It starts with everything. You see, even I don't know if you can see it, but you can download this yourself. Look at, it has the body regions, which you can use for labeling, which it will help you for your test, all the way to the, I don't know how but how do you do this? Anyway, I have it in the other one, so I'm sure you'll be able to download it too, because I was able to. I just don't know how to do it from here. I'm in a hurry, but it's really from the beginning, and then as you move on with the pages, it shows you drawings of histology, so the different tissues shows. But although it's just black and white, they use a pen, but it will still be very, very helpful for you in your studies. Tissues, then integumentary system, then the bones are there. Students like it because they get to for some students it helps them when they're coloring, so they remember the different surface markings of the bones. So that will be so Histology World, and then Lumen Histology. This stands for Loyola University in Chicago. It's a medical website. But I like it. I like their histology website, and so you can use that to help you, okay? So on Wednesday, I'm going to have a mini lab, just a pop quiz for you guys, histology.
I thought we had a regular quiz on Wednesday.
I'm already announcing that I'm going to have a pop quiz, just a mini pop quiz on Wednesday, okay? So just be aware. Just to find out if you're already familiar with your tissues or not, okay? That pop quiz, you can open your notes on Wednesday. So if you want to open your notes, that will help you. But of course, on the actual lab exam, there will be no notes. Just you bring your brain and your pen.
How many questions?
On Wednesday? I don't know. We'll see. So what do you think is this one? Yes, that's your neuron, okay? So as long as you see where is the cell? Where's the cell? This is the whole cell. All of this. So this is how it looks like under the microscope, right? So where's the nucleus? Right there. How many nucleus will this have? One. Very good. This one is not able to divide anymore, right? We discussed that because what organelle is absent?
Central.
Yes, very good. There's no more centrioles, so when it gets injured, the injury is permanent. Because it doesn't have any more centrioles, this cell will spend its lifetime in what phase in its life cycle? Yes, very good. Interface. Okay? So those are the types of questions you will encounter in the lab exam. Okay? So maybe I'll ask you even this cell is still metabolically active, true or false? It doesn't divide anymore, but it's still metabolically active. True or false?
True.
Yes, very good. Okay, it's still true. And then maybe I'll ask you, where do you find this in the body? So you're going to write down, where do you find this in the body?
In the brain.
Brain, okay. So then maybe the next question I'll ask you, the organ that you just cited where you find this in the body, what body cavity will that be found? So you answered brain. Where do you find that?
Cranial.
Yes, or dorsal body cavity. So cranial cavity or dorsal body cavity. That's the correct answer. So that's the style of questions that you will encounter in your lab exam. Okay? Okay. Next, what is this? No. The striations, skeletal muscle. It is muscle, skeletal muscle because of the striations. Right? Then I'll say maybe identify the structure under the pointer. Nucleus, very good. Then maybe I'll ask each cell will have how many of that one? This skeletal muscle, so it must have many. Remember, I ask you to know the difference. So skeletal muscle is striated, multinucleated, and voluntary. Okay? You will know that by heart by the time you come for your lab exam. We'll keep on practicing and practicing. It's multinucleated. Okay? Maybe I'll ask you, give me one function that this tissue is able to do that the others can't do. What? Give me one function for that structure. Huh? Heat generation. Very good. Heat generation. What else? Contraction, right? Then maybe I'll ask, for this specimen to be able to do its job, give me one organelle that must be found in abundance in every cell. One organelle that must be the organelle inside the cell. Remember the nucleus.
Mitochondria.
Yes, very good. Mitochondria. You can write mitochondria, right? Because mitochondria gives you
ATP.
yes, energy. So you see the style of questioning? Okay? So maybe then I will ask, because it gives you energy in the form of ATP, maybe I'll ask you, what kind of compound is this ATP that you're talking about? Is it organic or inorganic? ATP is?
Organic.
Yes, organic. You remember your inorganics is just your water, carbon dioxide, oxygen, acids, bases, and salts. Okay? Next. What is this tissue type? This is, you see the sausage. The sauce, yes. When you see sausage, and in the test, because like this one is connective tissue, you see the triangle, the pointy nucleus. So every tissue is glued together by connective tissue. That's what connect. So I'm going to make sure I point to a structure with the sausage. So if you see the sausage, besides if you see a lot of sausage, I must be asking for smooth muscle. Okay? I'm going to make sure I focus on a part of the muscle which shows a lot of sausage. Okay? So you're going to write smooth muscle. Maybe I'll ask you, where do you find this in the body? You give one location in the body, right? And then maybe I'll ask you, if damaged, injury to this structure is permanent, true or false? Yes, because remember, muscle does not have centrioles. So then maybe my next question will be, what type of tissue then will replace the injured? What type of tissue? Scar, which is connective. I'll accept scar, but I hope you remember connective tissue. But scar is still correct. I just hope that you remember connective. How about this one? You see the kinky? Kinky is rubber band. Yes, always you think elastic. Elastic rubber band. So elastic connective tissue. So maybe I'll ask you, identify the structure under the pointer. So those kinky will be your elastic fiber. So this is elastic tissue. So the structure under the pointer, the kinky, is your elastic fiber. Maybe I'll ask you in the test, in the skin, if this is injured, what will happen to the skin? If that gets injured, you will start having wrinkles. Okay? If it's the collagen fiber that's injured, you're going to have sagging skin. Like the cellulite will have sagging skin, right? But wrinkles, it's different. That's injury to your elastic fibers. Commonly injured by cigarette smoke and sunlight, sun damage, right? Maybe I'll ask you this. What is the most abundant compound that makes up this fiber? The most abundant organic compound that makes up this fiber. Compound. Collagen. What is collagen? That's very good. It is collagen. But what is organic compound is?
Water.
No. Water is inorganic. Protein. There's one more tip. If I ask you what is the most abundant organic compound, it's always protein. Right? Whatever. Maybe I have a bone there or cartilage there. It's always protein. And then if I ask you what is the most abundant inorganic compound present in every cell here, it must be always water. Okay? So if it's organic, it's always protein. Inorganic, it's always water. Okay? Then maybe I'll ask you, what did I say? So identify this. According to composition, this must be protein, right? The elastic fibers are made up of protein, right? Then maybe my next question will be, this organic compound is made up of what basic building blocks? It must be amino acids. Very good. I used to always ask also, so you're going to say, what's the most abundant organic compound? It's protein, right? So then I would also ask, in the past, I would ask, what organelles are necessary to make this organic compound? So you're going to write down the ribosomes, the Golgi body, and the endoplasmic reticulum, the rough endoplasmic reticulum. Okay? The rough, yeah, yes. Okay? What's this? What's this? Yes, very good. It's reticular connective tissue. Where do you find this in the body? You think liver and lymph nodes, where there must be some sort of filtering. Spleen, very good. Okay? And so then maybe I'll ask you, let's go to the next one. This one is obviously, yes. Then maybe I'll ask you, all the cells here are nucleated, true or false? All the cells are nucleated, meaning each and every cell has a nucleus, true or false? Yes, it's true, right? You don't see it because most of the cells are, the parts of the cell are just obstructed from your view because of this. Then I always used to like to point here outside, identify the structure under the pointer. What's the answer? What's this? No, what's adipose? It's lipid. That's the fat. The whole cell is the adipocyte. But if I say identify the structure in the pointer, that's your lipid, that's the fat, right? Then maybe, yeah, the fat. Maybe I'll ask you what type of compound is this, organic or inorganic? Organic. Maybe then I'll ask, what's the function of this one? It is your stored energy. Then maybe I'll ask, what do you think? The basic building blocks of that compound of the fat are mainly held by what type of bond? What do you think? Would it be ionic? What did you say?
Covalent.
Yes, very good. It is covalent, right? Must not be ionic because ionic is very easily broken down, but they're covalent. All organic compounds are held together mainly by covalent bonds. Then, what's the function of this one? What else? Maybe I'll say, in addition to storing energy, give me one other function.
Cushioning.
Cushioning, okay. Protection, okay. Next. Now you see, it's not sausage, it is pointy, so it must be, see the pointing? It's not sausage. It must be collagen. If you wrote dense, regular connective tissue, that is also correct. It's just too long.
Dense, regular tissue.
Dense, regular, it's easier to write collagen, isn't it? And then where do you find this in the body? Where do you find collagen in the body? Tendons, very good. Tendons in your under the skin. You can write under your skin, right? You have collagen there too. And so maybe I'll say in the skin. What happens to the skin if this gets injured? Sagging skin. Okay? Next, identify bone, osseous connective tissue. Okay? So, I'll say each and every cell here are metabolically active, true or false?
True.
Yes. They're metabolically active. Okay? What's the most abundant inorganic compound here? What's the answer always? No, that's organic. Water. Inorganic. Yes. Okay? Here's my question. Identify this organ. Yes, the answer is skin. Okay? So, and then I'll say, there are two basic tissue types you see here. What is the tissue type of the more superficial part? Superficial, directional terms. Yes, epithelium. And then the deeper part is connective tissue. Okay? So you should be able to give me the function of the superficial part. Do you think this superficial part is epithelium? Do you think exchange happens here?
Yes. Well, no.
No, because it's many layers, right? It must be for protection. Okay? Okay, identify this one. No.
I'm sorry.
Columnar phase.
What's the correct answer? You're not gonna write. What did you write? What did you write? Telophase or anaphase? If you wrote mitosis, that's not a complete answer. Okay? So the correct answer is you can write telophase or anaphase, and then maybe I'll ask, assume this is mitosis. How many daughter cells will be produced at the conclusion of this type of cell division? How many? 2. Then maybe assume this is your, maybe I'm not going to write this is my, I'm going to say, assume this is your skin cell. At this stage, there are how many chromosomes? Right now, right here, how many chromosomes? Yes, very good, 92. Okay? Then identify this one. Prophase, very good, right? So, at this point, how many chromosomes? How many chromosomes here at this point? No, it's
92.
already 92 already, right? Look at the difference between this one and this one in interface. This is lighter in color, this is darker because you doubled up the chromosomes. You remember, diploid. Okay, so this is diploid, if it's a somatic cell. What is this tissue type over here on top? What's this one, the whole thing? The clue. There's no obvious shape, right? It's confusing, it's transitional everything. Right? There's no, I'm not sure what shape it is. This looks round, this looks square, it is transitional. Where do you find this in the body? Transitional is only found in your, the easiest to remember is your bladder, right? Not uterus. Uterus is smooth muscle. The bladder. Urinary system. It transitions from flat to many layers. Okay? And then maybe I'll ask you, the basic tissue type represented by this one, which is epithelium, has the highest incidence of cancer. Why?
Lack of water.
Why do you think it has the highest incidence of the 4 basic tissue types? Epithelium will have the highest incidence or chance of becoming cancer. Why? Why do you think? It's obvious. What do you think? Yes, it is exposed. It's the one that's constantly, so it's the one that can always be traumatized, right? Whereas the connective tissue, the muscle and nervous, it's protected always by this one. So that's the first one to encounter harmful chemicals. Okay? So it always has the highest incidence of cancer. Okay? Then, it also related to that one, I used to ask, this basic tissue type has the highest rate of cell division. Why? Same thing. Because it's exposed, constant wear and tear, so you have to constantly replace what is injured or what dies up there. Does it make sense? It's exposed. So what's the tissue type of this one here? What did you say? Connective tissue, right? You see the pointy, that must be collagen fibers. Okay, what's this one? Obviously, it is. Always make sure to point this. Yes, pseudostratified ciliated columnar epithelium. Once you see cilia, it's always pseudostratified ciliated columnar epithelium. And then I'll ask, maybe identify the structure under the pointer, that is cilia. What's the function of cilia?
To move stuff along
Yes.
the cell surface.
Then maybe I'll ask you, it was one of my favorite questions always. In your respiratory system, predict what happens if this gets injured. Yeah, the patient will start coughing because it's not able to brush up. Every day we're inhaling microscopic particles. So every day when we swallow, part of what we're swallowing is phlegm. But once that gets injured, we have to now cough it out. Otherwise, you end up with pneumonia. Okay? What's this one? Very obviously, yes, simple columnar epithelium. Okay? Where do you find this in the body? In your GI tract. Think GI tract. Okay? Okay. Then, my favorite, what's this tissue type? Yes, simple what? Yes, simple squamous epithelium. So then my question will be, how many layers of cells do you think will this tissue be made of? One, just one. It's simple, right? So maybe I'll ask you, give me one function that this is able to do that stratified is not able to do. Filtration, exchange, right? With many layers, you cannot. How about with this one? How many layers of cells do you see here?
Many.
No. Yes, one. Very good. Because it's pseudo. It's a fake stratified. Just don't forget. This is where I see some answers. They write 7 layers. They write 16 layers. It's just one. Remember the word pseudo. It's a fake it's just one layer. And I used to always like to ask that. Identify this organ. Skin. And that's our next lecture. I'll ask you to identify this structure. This is your hair. That's the hair. Then maybe I'll ask, what is the basic tissue type of this structure? It is epithelium. We're going to study that next. So what about this one? Yes, it's areolar. This is the least specialized of all the basic, of all the connective tissue types, meaning this is the one under our skin. So if we eat too much fat, it can just become adipose tissue. Or if we exercise, then collagen will predominate. So it's the least specialized. That's the one I said when you lift the skin of the chicken, that white cobwebby structure, that's your areolar connective tissue. Identify this structure. This is collagen fiber. Collagen. And what is the basic, what's the most abundant organic compound for this one? Protein. What are the basic building blocks of protein?
Amino acids.
Yes. What's the most abundant inorganic compound here? Water. How about the white spot? What is that part? Yes, very good. That's the ground substance. Okay? That's the ground substance. White part. Yeah. So what's the function of that ground substance? It holds everything in place, right? That's the glucosamine that we take when we get old. Okay? So you take glucosamine because that's the one that keeps everything in place. What's this one? Cartilage. So identify the structure under the pointer, these individual structures right here. These are your chondrocytes. Those are the cells. Yes, it's hyaline cartilage. Very good. Maybe my next question will be, there are fibers in this specimen. True or false? What do you think? It's connective tissue. There are fibers. Remember, what makes connective tissue connective tissue? Cells, fibers, and ground substance. So there is collagen fibers here, in fact, except that the composition is equal to the ground substance, so it looks very clear. But there's collagen fibers here. Where do you find this in the body? Yes, the ends of the long bones. Maybe I'll ask you in that part of the body that you cited, what do you think is the function? In that part, if you wrote the ends of long bones, what do you think is the function? Pain-free movement, what do you think, right? That's why you have cartilage there. Okay? What's this? Yes, very good. Cardiac muscle. You know, there are some slides there, cardiac muscle slides. The intercalated disc is not very obvious. Sometimes instead of a dark line like that, there's a white space, very thin white space in between. That is also an intercalated disc. Maybe I'll ask you, what type of junction proteins or will be present in abundance in this tissue type? Remember your desmosome, adherens. It must be the gap junctions. Why? When cardiac muscle contracts, it contracts like it's one. It's important to have gap junctions there to facilitate the fast propagation of action potential. How about, what is the tissue type of this one? What do you think? No, this is not epithelium. This is. So what is this one? What's this? What did you say? It's adipose tissue, connective tissue. There's fat in between your cardiac muscle cells. Okay? So that's just a sample. Today, Wednesday, we're going to have another round until you get familiar. Then we're going to so we're done with chapter 4. Today we start with chapter 5. Integumentary system. All books always start with the integumentary system because that's the one that we see. Before we get, when you receive a present, you have to take out the wrapper. Is that what you say? Take out the wrapper. Take off the wrapper. You have to take off the wrapper first before you can see the gift. So there's your wrapping paper, your integumentary system, which is the skin. Okay? The reason why it's called integumentary system, it's because the most predominant organ of the integumentary system is your skin. Another term for skin is integument. So that's why you call it integumentary system. The other organs of the integumentary system, just think of anything and everything that is on your skin. You have your hair, you have your nails, and then you sweat, so you have glands. So the organs of the integumentary system, you have your skin, your hair, your nails, and your glands. I'm sure you know dermatology is the branch of medicine that deals with problems of the integumentary system. So before we move on any further, what is the function of the integumentary system? Look at it, covers and it protects. This is your first line of defense. Don't they say that your best defense is an intact skin? Once there's a break in that skin, that's when bacteria can go in and cause trouble. That's why it's always wise to wear gloves. Whatever kind of activity you're doing, you never know what chemicals are in whatever you're touching, especially when you're dealing in a medical environment or in the lab. Always wear gloves so that those chemicals will not enter. Remember that we're going to talk about that in a minute. Okay. Another function of the skin, look at, it's important for vitamin D formation. What's vitamin D important for? Why do we need vitamin D? Bone? Yeah. It's important for the absorption of calcium, right? So we need vitamin. You heard of VDDS, right? Vitamin D deficiency syndrome, which is very common in this part of the country, right? But if you experience periods of depression, even diabetes is linked with vitamin D deficiency, or pain like muscle joint aches and pain in your gums and insomnia, all of those, a lot of times, and then you go see, they send you to a psychiatrist. A lot of times it can just be traced to vitamin D deficiency. That's why I like taking multivitamins every day, just to make sure I have adequate levels of my vitamins. This vitamin D synthesis, what is the parent molecule of vitamin D? Remember I told you to highlight that? Cholesterol. Very good, cholesterol. So see, that's why we need cholesterol. So how do you get your vitamin D? You really have to be out there in the sun, under the sun. The sun, the UV rays of the sun will convert the cholesterol to vitamin D. It's really a process. Converts it to cholecalciferol, then it goes to the liver. The liver will convert that to vitamin D2, then goes to the kidneys. The kidneys convert that to vitamin D3. But we're going to get to that part when we go to Bio 242. For now, you should know that you really have to be under the sun. You know the old people? They get cold very quickly. And so a lot of times they just stay in their house. They don't go outside. And they just stand like this. You want to make sure that you open the windows. They can get their vitamin D that way. Because if the window is closed, that glass, it blocks the UV rays that's important for the conversion of vitamin D. It cannot. So even though they're out there, they will still suffer from vitamin D deficiency. Okay? What is another function? So, thermoregulation, right? By sweating, and you also have your goosebumps. How about this one? it excretes waste, which is urea. This is the most, so sweat is the waste. The most abundant component or the most abundant waste product in sweat is urea. Urea is a toxic substance. So we mostly get rid of it in our pee-pee, but some of it through sweat. Where do you get this urea? From amino acid breakdown, right? So like if you eat too much proteins, sometimes you sweat a lot. It also depends on what you eat. So some people, they say, I don't really sweat that much, especially those who are vegetarians maybe, or those who are not metabolically active, they don't sweat that much. Any protein breakdown, you have to get rid of that one. So you may sweat. You heard of this one, by the way? Acid mantle. You heard of that one? It's a you know what mantle is, right? You cover. So the skin really is one big acid mantle. Sweat is acidic, and we have that insensible sweat. And that acid mantle is actually very good at preventing bacterial overgrowth, because there's bacteria on and in us. If you've taken microbiology, what did Wendy say? For every one human cell, there will be 10 bacteria. So we're overpowered by bacteria. Overpowered? Yeah.
Overrun.
Outnumbered. That's the correct. Outnumbered by bacteria. Can you imagine if you give them a chance, they will cause problems. So that acid mantle, the sweat on the skin, it creates an acidic pH. It kills the bacteria or prevents them from being a threat to our health. Okay? It also reduces water loss. That's why we can sit in the bathtub for long periods, right? But remember, what's that? It's water resistant but not waterproof, right? The skin. So that's why, like my husband, he likes to sit in the bathtub for long periods. When he gets out of the bathtub, everything wrinkles. The fingers, that's right. Just remember, that's why you can die from dehydration, right? Like if you get stranded in the ocean, you can still die from dehydration because water moves by osmosis. So don't forget that. And does this make sense? It's very sensitive. Can you imagine if your skin is not sensitive? I'll be cutting you with a knife. You don't feel it. You'll be injured inside. So to protect your internal organs, it has a lot of receptors. We're going to study these different receptors when we take up the nervous system. Okay? So we're ready to study the first part of the first organ of the skin, which is your integument right here. So that is your skin. And the skin is made up, the integument is made up of two parts. There is your epidermis. Directional terms, epidermis is superficial to the dermis. Okay? So the skin is made up of two parts. Superficial epidermis and deeper dermis. There is a hypodermis, which is your subcutaneous layer. I always like to use the word hypodermis. But you need to remember that that is not part of your skin. It's not. The function of the hypodermis is to anchor your skin to the rest of the body. If not for the hypodermis, your skin will fall off by gravity, right? So is the hypodermis part of the skin? No. The skin is only made up of epidermis and dermis. Watch, in the test, one of you will, maybe several of you will still get that wrong. The skin is made up of Epidermis, dermis, hypodermis. True or false? Someone will write true. It's false. Okay? I like to use the word hypodermis. The hypodermis, this is where we put our subcutaneous injections, right? The reason is there's lots and lots of blood vessels here. So it's ideal for your injections, subcutaneous injections. Okay? So let's look at the different parts of the skin. First, we look at the epidermis. What is the basic tissue type of the epidermis, you think? What is the basic tissue type of this one? Is it epithelium, connective, muscle, or nervous? Yes, it's epithelium, right? So what do you think? Is it simple or stratified? Stratified. And then the topmost is flat right there, so it is stratified squamous. Stratified squamous epithelium. That is the composition of your epidermis. So here it is. These are the cells of the epidermis beginning here. I know it begins here because it's very cellular, you see? Okay? So stratified squamous epithelium. This stratified squamous epithelium is made up of cells. What are the cells that you find here? There are 4 major types of cells. Majority of these cells are called keratinocytes. That's the majority of the cells that make up your epidermis. You call them keratinocytes. Are you following? Okay? So, what do keratinocytes do for you? They make keratin, which is a tough protein. Like your nails, that's keratin, right? And isn't that good for protection? It is a protein. So what do you think? How do the cells make it? By protein synthesis. See? That's why we had to talk about your protein synthesis. Transcription, translation. Don't forget that, right? Okay? So these cells, in addition to your keratinocytes, there are 3 other cells that your epidermis, your stratified squamous epithelium contain. The next important cell will be your melanocytes. What do melanocytes do? What do melanocytes do? They make melanin. What is melanin? What is the composition of melanin? Another protein again. See? All cells are busy. Protein synthesis is a very predominant part in the life cycle of any cell in the body. So melanin, what's the function of melanin? What's the function of melanin? Correct. It gives you your skin color, but it's very important in protecting your cells from sun damage. So look at this picture over here. Actually, your melanocytes are the ones that make melanin. But every keratinocyte will have melanin. Do you follow? So only the melanocytes make melanin, but they share the wealth. So how do you think they spread that melanin pigment? They do right here. You see? So this is the melanocyte making melanin pigments. And once the melanin pigments are made, they release that so that all the keratinocytes will eventually have melanin. Okay? What's that process? Where you release substances outside the cell? What's that process? Exocytosis. Maybe I'll ask you that in the test, just so I know that you remember the terms. Exocytosis, right? Look at where melanin is concentrated on the cell. The book Hole's Anatomy, I like it. He wrote sunny side up. So you see, look at it covers the nucleus. Isn't it the most precious part of the cell, right? Protects, that's where your DNA is. So look at where the melanin is concentrated. covering the nucleus sunny side up. So the part of the skin that's exposed to the cell, to the sun, the melanin pigments are like an umbrella. Okay? Why? Because we don't want that to be damaged. Remember, that can be the beginning of cancer. Right? So that's why melanocytes are important. Do we all have the same amount of melanocytes? Yes. Right? It's the amount of melanin that makes me darker than you, and the others darker. What is the danger if melanocytes start mutating? They're also prone to sun damage, right? It's not only these skin cells that can be prone to sun damage. Also, these melanocytes can be affected by sun damage. The danger is they can become, yes, called melanoma. Melanoma is one of the most aggressive cancers. Why? Look at this picture. Look at the way the melanocytes, anatomically, how they look like. They look like octopus, right? These are the processes, okay? And they like to spread the web up like that, unload their melanin, okay? When they become cancer, they are very aggressive because look at, they then go down. Look at those processes. So they're very invasive and they spread quickly. So that's why, you know, like with me in the trunk of my car, I always have that umbrella hat. So Lily and I would like to go, go to the whatever fair. People always laugh at us because Lily's wearing an umbrella hat. It's really an umbrella that you wear as a hat. And me too. And people think but I don't care. It's protection. They say you see the damage, it's already done. When you see there's damage, it's irreversible. So you want to protect yourself. And by the way, it's not only excessive sun damage that can maybe be a danger to development of cancer, right? Like those tanning salons. Any UV damage can cause skin cancer. And I always remind the class about my student at Pierce College. Yes.
I was just going to ask, so they're most abundant in the basal layer, right?
Very good, yes. We're going to talk about the different layers, okay? So next.
I want to hear the story about your student after
Oh, well, yes. She, after this part of the lecture, she came up to me. She said, you were talking about tanning salons. She said, I've been going to the tanning salon since I was 16 and now I'm 21. But I noticed this small spot right here. And she just noticed it for 3 months now. She said, do I have to be worried? And I said, I'd be worried. It may be nothing, but it could be something. And what was it? It was something. So you see, from where? Tanning beds. So just remember that it's not only the sun itself, okay? The other cells that you find in the epidermis, you have your Langerhans cell. You write your letter L with the capital L, so you remember that Langerhans cells, they eat, so they must provide some sort of immune function. So in case there's bacteria that enter, you have your Langerhans cells spread apart that can prevent them from entering deeper, okay? And then finally, you have your Merkel cells, which is a nerve organ. So that's why your skin is very sensitive to touch. So this epidermis, the superficial part of the cell, is made up of several layers. You see that? In the test, if this was going to come out, I'm already going to label them for you. All the layers will be labeled for you, so you don't have to worry about that. So the different layers, the deepest is the stratum basale. Again, this will already be labeled for you. Next, you have the spinosum, then granulosum, then you have your lucidum and the corneum. You just need to know, in the past I used to have a matching type. So A, B, C. So A is this one, B, C, D, E, F, all D, and then G will be none. So what's the stratum basale? This is the deepest part of the cell. One of the characteristics of epithelium is it is avascular. You remember, it doesn't have its own blood supply, right? So look at this picture. If I look at this picture, I'm thinking of the 5 layers. Which one would be the healthiest? It must be this basale, right? Which one will have the highest rate of cell division? It must be the stratum basale. Does it make sense? It's closest to the blood supply right here. Over here, avascular. So, by the time they reach up here, this is dead. Can you picture in your head, this one has the highest rate of cell division. So, let's trace this cell. If this cell divides, it will produce 2 cells. So, there's the original cell and then the next cell, right? Right? So, see, it gets farther and farther. Then, if this divides again, if this will continue to divide, right? So, this will continue to divide, produce another one. It keeps, this one then, this green cell that we're trying to follow, it will just keep being pushed up and up and up as this continues to divide. You see that? So, that's why by the time you get here, it's dead. But what is it doing? This keratinocyte, these are keratinocytes by the way, as they're being pushed up, they're busy making keratin. Okay? So stratum basale, highest rate of cell division, very healthy. Lots of stem cells here. By the time we get to the stratum granulosum, you see granulosum, next to granulosum, right, transitional layer. This is where it transitions from living to dead. So here they start dying. And look at, they start accumulating lots of, it's called lamellar granules. That's why it says granulosum. But it's nothing but oil. Oil granules in there. In addition to your keratin. So what's the function of the oil? Doesn't that create a very effective barrier? And won't that make them stuck together? Like the grout in your tiles, right? So that's why if you're applying any kind of cream or a patch, a skin patch, you notice it's always oil-based. Water-based medicine or ointment is not going to be as effective as the oil-based. Because the water-based will be repelled by this one. So you're just wasting your money. Right? So you always want oil-based. Okay? So this, by the time you get to the stratum corneum, this is all dead. Each and every, what do you think? Do you see here nucleus? Right? There's nucleus. What do you think over here? Will there be nucleus here? No more. No more organ. It's dead. It's just dead keratinocytes filled with keratin, which is your top protein to protect you. Okay? So what do you think? Who woke up this morning applying their oil of Olay and all that stuff? Or maybe you don't like, maybe you like the expensive, the Elizabeth Arden or whatever. You know, when we apply these things, if it makes you feel good, why not, right? Just remember that what you are nourishing today is gone tomorrow.
Okay.
So that's why the skincare companies, it's a big business.
Right.
Because we get hooked. We can't stop. Because we keep shedding the one that we nourished. It's gone. Tomorrow I gotta do it again, you see? Because it's a different one that I'm nourishing. So don't forget that. That's why this one constantly sheds. Doesn't it shed? When you walk and you see that spotlight, you see some air particles moving, that's your skin. And that's why we continue to dust, right? Why is my house so dirty? I keep dusting. That's you.
Right.
Your skin shedding. And we can't leave it out because what's the composition? Organic compound. That's food for the dust mite. You see?
Yeah.
So that's why you have to keep cleaning. It's just normal, right? we have to do. Okay? And what do you think? We'll talk about that later on. Okay, so the next part, I have to remember what we're going to talk about later. By the way, this stratum lucidum is only present in thick skin. So there's two types of skin, thick skin and thin skin, right? Where do you have thick skin? Yes. Yes, very good, thick skin. How about if you're like my mother who likes to go to Red Wing Casino and she likes to play that slot machine? After a while, you have that callus there. Is that thick skin? So this is still thin skin. Only this is thick. What is that? That is an overgrowth of this stratum corneum. That's nothing but extra layers of stratum corneum. Okay? So it's still thin skin. So callus, like your, what do you call it? Dandruff, stratum corneum, right? Okay? Okay. Next will be your dermis, which is the deeper part of the skin. So what do you think is the function of the dermis? You don't need to remember these two parts. What's the composition of this one? What basic tissue type? It is not epithelium, but it is connective tissue. Here is where we'll find your collagen fibers and elastic fibers. And you know what will happen to your skin if the collagen gets injured or if the elastic fibers gets injured, okay? So one is sagging skin, the other one is wrinkles, okay? And here, look at this is where you have blood vessels. So really, the best to nourish your skin is not to apply from here because here, what you're nourishing is dead. What you want is to nourish the one right here. And you nourish it by providing good nutrition in your blood, right? C for collagen. Vitamin C rich foods. It's really the best for skin. You know, when you eat properly, it shows in your skin. Don't they say that? And you see me in the morning, maybe that's why I'm late. Because I like to rub my skin like that. Doesn't it encourage circulation when you rub? So you rub, you encourage circulation. That's why cigarette smoke is not that good because it promotes clots, remember? You talked about that in your Bio 242. Okay, so next will be skin color. What do you think? Of course, the most common cause for skin color is your melanin. Where is melanin? In the epidermis. But do you think the dermis also plays a role in skin color? I'm thinking yes, right? When you blush or when you're pale. So, when you blush, pallor, when you're pale, pallor, right? You know this one, you're pale skin. How about erythema? You heard of this one? Reddish or blushing, right? You know of this one, cyanosis. What's this one?
Blue.
Yes, because of
Lack of oxygen.
lack of oxygen. So these are all dermal in origin, right? What about this one?
Yellow.
Yes, because of bile.
There's bilirubin.
Yes, bilirubin. Okay? So it's not only the epidermis that contributes to your skin. How about keratin? Keratin is a pigment that gives you yellowish color. I found this on the internet. Look at this girl. I don't know if you can see, but look at, she became yellowish after 21 days. So she just tried to experiment. So it can really lead to a yellowish discoloration of the skin. Okay? Then you have the subcutaneous layer. Remember that this is not a part of the skin. It anchors. By the way, look at the epidermis. It's not a flat like layer. What do you call it? It's called dip. What's that term? Anyway, the way the epidermis is attached to your dermis is it looks like the egg grates, you see? Because if it was just one straight line like that, the epidermis will easily fall off. So it has to interlock with your dermis so that it doesn't come off, it doesn't fall off. Okay? So look at this, this arrangement of your epidermis with the dermis leads to the fingerprints right here, and your fingerprint is different from mine, from yours, and that can identify if you're the one who took the cookie from the cookie jar. They can identify by your fingerprints. We'll finish up with the rest of the integumentary system after the break.